What is happening, everybody? We are back for some more quadratic functions and their graphs. Today, our essential question is how do we determine domain and range of a quadratic functioning? How do I determine whether it's increasing or decreasing? So domain, range, increasing, decreasing. Those are going to be our two kind of key points today as we go through this lesson. Real quick, before you begin, pause the video and see if you can fill out this chart so that way with this vocabulary we can all talk about it together. All right, the other word that is opposed to domain is the range. You got it. Now, the opposite of an output would be an input. Remember, functions are nothing more than where numbers go in and numbers come out. Quadratics are functions a lot of times because numbers go in, numbers come out. And opposite of the x values are the y values. All right. So what you're looking at here is basically just some notes. So we're going to talk about some notes very quickly, and then we'll get into some examples. So let's read this together. Domain and range. Substituting any real value of x into a quadratic equation results in a real number. Therefore, in general, unless we restrict it, the domain of any quadratic function is all real numbers. Think about this. Let's take a quadratic. Y equals x squared plus 3x. That's a quadratic equation. Is there any x value that I'm not allowed to plug in here? Of course not. You could plug in integers, you could plug in decimals and fractions, and even irrational numbers, and you'll get an output. So the x values, or the domain, is all real numbers unless it's restricted. The range, however, depends on the vertex. Remember, parabolas go down to a minimum or they go up to a maximum. So the range of how many outputs there are going to stop at a certain amount high or a certain amount low, depending on the direction that the parabola opens. So all this says, I'm going to paraphrase it, is that when you're looking left to right, you're looking at the x values, you can determine the domain. What's the leftmost and what's the rightmost x value? If there are arrows on your parabola, then it goes forever left, forever right. To determine the range, we look up, down. So how high does this go? Well, it stops at 5. So this is a maximum value of 5. So I would say that the highest y value is 5. So the range is y is less than or equal to 5, as where the domain is all real numbers, or from negative infinity to positive infinity. All right, so let's try this with an example. All right, here's our quadratic. Now, we're going to graph this thing. This is going to be our x-axis. This is going to be our y-axis. All right? So what I want to do first is I want to find the vertex. So I want to take x equals negative b over 2a. I'm going to type in, or write in this case, x equals negative 4 over 2 times negative 1. The reason a is negative 1 is because there's a negative 1 in front of this x. And we get x equals negative 4 over negative 2 is 2, so it's 2 comma something. Now, in order to get that something, you could do it one of two ways. You could plug the x in, or you can go to your table of values and just plug this into your y equals and then figure it out from there. If you plug it in, you will get 2, negative 2. So I'm going to plot that point right there. That's going to be my vertex. Now, since this is a negative leading coefficient, I know that this is going to open down, which is going to make this a maximum. So this is going to be a maximum point. In other words, this is the highest output or y value we will have. The x-intercepts can be found by graphing it, really. Let's graph this first. So remember, I like to take the vertex and put that in the middle and then get a few points on either side. So you're going to get 1, -3. You will get 0, -6. And let's put 3 with -3 and 4 with -6. Now you might say, where am I getting all these values from? Well, just in my calculator, just going to the table of values. It just saves time so you don't have to plug all these in and figure it out that way. So 0, -6, 2, 3, 4, 5, 6. 1, -3, 3, -3, and 4, -6. Now, this is the domain we used, but there's no restricted domain. So we're going to go just slightly past it with some arrows. Slightly past it with some arrows. Don't go too far, again, because you end up kind of shooting it off in a direction that it really doesn't go. All right? So what are the x-intercepts? Well, this thing doesn't cross the x-axis, so we're going to say none. What does that tell us about this quadratic equation? First off, this does not factor, so what are we left with? How do I find the zeros or the x-intercepts or the roots when this does not factor? We're going to use quadratic formula. The problem with these are they are imaginary roots. So let's find them this way. X equals -b plus or minus the square root of b squared minus 4ac. And what you're going to notice all over 2a. What you're going to notice is we're going to end up with a negative number as our discriminant. So this is going to be 16 minus 24. 4 times 1 is 4, and 4 times 6 is 24. You could type this all in your calculator and get it that way, all over -2. So you get -4 plus or minus the square root of, well, 24 minus 16 is going to be -8. So we're going to put -8 there, over -2, and I'll just simplify this for us. -4 plus or minus 2i rad 2 over -2, which is 2 plus or minus I rad 2. Now what you should probably do is pause the video and kind of go through this whole thing slowly. I should probably go through it one more time just to make sure we did it right. So let's just do that together real quick. If you want to pause the video and try this on your own, you can. But we're looking for the zeros, okay? So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So everything's done correctly. 16 minus 24 is -8. So our discriminant is -8. And what did we learn in our discriminant video is that when the discriminant's a negative, that means that it's going to have imaginary roots. In other words, it's not going to cross the x-axis. So then this is 2 rad 2, but we'll take an I out because of the negative. And then everything divides out by 2, and we should get 2 plus or minus I rad 2. So that's our root 2 plus or minus I rad 2. So these are imaginary roots. So it actually doesn't have any real roots. Now, here comes the 2 words of the day, domain and range. All right. This thing goes forever left and forever right. So we're going to say our domain is from -infinity to +infinity. We could also say that like this. X is in between infinity and -infinity. Whether you want to use an inequality or interval notation, either one is fine, unless you're told specifically which one to use. All right, so the range. Now, here's where it gets a little different. The range does go forever down, but it does not go forever high. The highest point, let's just write this in here, is 2, -2. So the highest point is -2. So we're going to say our range is from -infinity all the way to -2. Now, in interval notation, infinity symbols never get hard brackets because they're not numbers, they are concepts. The -2 is included in our set. So we will put a hard bracket around that. Or we could use inequality notation, which we could just say the y values are less than or equal to -2. Now keep in mind, if this were opening up, we would say the y values are greater than or equal to -2 because this would be a minimum point and our lowest value. So just be careful when you state the range that you make sure it's going up or down. All right, so all this is just some more notes for you to read through, but you guys already know this. If the a value is positive, it opens up, we have a minimum, and both ends approach positive infinity. They both go up forever and out forever, right? If a is negative,